Good morning, children. Today, let us start the properties of colloidal particles. The first property is Brownian movement. Now, children, colloidal particles are having Brownian movement. What is the meaning of Brownian movement? Now, the colloidal particles, they move in a zigzag motion. Zigzag motion. This is called Brownian movement. What is that? The colloidal particles, they move in a random zigzag motion. This motion is called Brownian movement. Now, children, what is the reason for the cause why they move in a random zigzag motion? When colloidal particles are viewed through a microscope, the colloidal particles are seen to be in a state of continuous zigzag motion. For the first time, this motion was observed by British botanist Robert Brown in 1827. He discovered that the pollen grains suspended in water do not remain at rest but move about continuously and randomly in all the directions. So later on, he observed that even the colloidal particles, colloidal solution to the particles, they are also moving in random zigzag motion. Now, children, what is the cause of the Brownian movement? The Brownian movement has been explained due to the unbalanced bombardment of the particles by the molecules of the dispersion medium. So the molecules of the dispersion medium are constantly colliding with the particles of the dispersed phase. Are you following, children? The colloidal dispersed phase constantly colliding with the dispersed particle. So therefore, the impact of the dispersion medium particles are unequal, so causing a zigzag motion for the dispersed particles. Okay, children, clear? Now next, optical property, that is Tyndall effect. Now, optical means light property. Children, we have to take two beakers. In one beaker, true solution. In another beaker, colloidal solution. When white light is passed through the true solution, the path of the light is not visible. The reason is the size of the true solution particle is so small, so they can absorb but they cannot scatter the light in all the direction. That is due to the small size of the particles. Now, meaning colloidal solution, children, is the path of the source, light source. When light is passed through the colloidal solution, the colloidal solution, it can absorb the light and it can scatter the light in all the directions. This is the scattered light. This is the microscope. After passing light through the colloidal solution, when it is viewed through the microscope, okay, children, are you following? So the colloidal particle scattered the light and the path of the light is visible to your naked eye. Okay, this is known as the Tyndall cone. This is known as the Tyndall cone. Why the path of the light is visible? That is, the colloidal particles, they scatter the light in all the directions. Are you following, children? The colloidal particles, they scatter the light in all the directions. How will you define Tyndall effect? The phenomenon of scattering of light by colloidal particles, as a result of which the path of the beam becomes visible, is called Tyndall effect. What is that? The phenomenon of scattering of light by the colloidal particles, as a result of which the path of the beam becomes visible, is called Tyndall effect. Okay, and the illuminated path of the beam is called Tyndall cone. Okay, children, and the Tyndall effect confirms the heterogeneous system of the colloidal solution. I repeat children, the phenomenon of scattering of light by the colloidal particle as a result of which the path of the beam is visible is known as Tyndall effect, and the path is known as the Tyndall cone. Now next children, electrical properties. Now children, electrical properties may be studied electrophoresis or cataphoresis. Electrophoresis or cataphoresis. What is that? Now children, we have to take a U-shaped tube. On both the sides of the limbs of the U-shaped tube, 2 electrodes are fitted. Okay, 2 electrodes are fitted. This is a U-shaped tube. Now 2 electrodes are fitted. Here in the U-shaped tube, the colloidal solution is there, and these 2 electrodes, when they are connected to the source of the electric current, okay, depending upon the charge on the colloidal particle, these colloidal particles may move towards the oppositely charged electrode. Now for example, this is the positive electrode, this is the negative electrode. If they carry colloidal particle, if they carry positive charge, then these colloidal particles migrate towards the negatively charged plane, indicating that they are made up of positively charged. Okay, so when near the negatively charged rod, the colloidal site, the volume of the solution will increase. Okay. Now near the negatively charged plate, the volume the level of the solution will increase. So this experiment is indicating that colloidal particles, they carry the charge. Okay children, clear? Now this phenomenon is known as electrophoresis or cataphoresis. What is electrophoresis or cataphoresis? The movement of the colloidal particles. Are you following children? The phenomenon of movement of colloidal particles after the application of the electric current is known as electrophoresis. I'll repeat the experiment children. We have to take U-shaped tube, colloidal solution is filled, both the ends 2 electrodes are fitted. When these electrodes are connected to the battery, depending upon the charge on the colloidal particle, they move towards the oppositely charged electrode. The level in this limb increases and here it increases. If they carry positively charged, then the solution will move towards the negatively charged plane, indicating that they are positively charged. How do you know? Here the volume will increase, the solution will rise up, here it will decreases. This phenomenon is known as electrophoresis or cataphoresis. How will you define children? The phenomenon of movement of colloidal particles under the influence of the electric field is known as electrophoresis or cataphoresis.